Okay, welcome back. Today we're gonna cover kind of a couple separate, like two main topics related to the cell. First, we're gonna do some kind of cell scripting, mainly related to Bash, which is like the cell that most of you will start in Mac or like most Linux systems. That's the default cell, and it's also kind of backward compatible through other cells like CSH. It's pretty nice. And then we're gonna cover some kind of other cell tools that are really convenient, so you avoid doing like really repetitive tasks, like looking for some piece of code or for some elusive file. And there are really nice built-in commands that will kind of really help you to do those things. So yesterday we already kind of introduced you to the cell and like some of its quirks and like how you start executing commands, redirecting them. Today we're gonna kind of cover more about like the syntax of like what are like the variables, the control flow functions of cell. So for example, once you're kind of drop into a cell, say you want to kind of define a variable, which is kind of one of the first things you learn to do in a programming language. Here, you could do something like foo equals var. And now we can access the value of foo by doing $foo. And that's var, perfect. One quirk that you need to be aware is that like spaces are really critical when you're dealing with Bash, mainly because spaces are reserved and that will be for separating arguments. So for example, something like foo equals var won't work, and the cell is gonna tell you why it's not working. It's because the foo command is not working, like foo is not existent. And here, what is actually happening, we're not assigning foo to var. What is happening is we're calling the foo program with the first argument equals sign and the second argument var. And in general, whenever you are having some issues, some files with the spaces, you will need to be careful about that. You need to be careful about like quoting strings to that. So going into that, how you do strings in Bash, there are two ways that you can define a string. You can define strings using double quotes, and you can define strings using single quotes. However, for literal strings, they are equivalent, but for the rest, they are not equivalent. So for example, if we do equals $value is $foo, the $foo has been kind of like expanded, like a string substituted to the value of the foo variable in the cell. Whereas if we do this with a simple string, we are just getting the $foo as it is. And like single quotes won't be replacing. And again, it's really easy to kind of write a script, assume that this is kind of like Python that you might be more familiar with, and not realize all that. And this is the way you will assign variables. Then Bash has a lot of like control flow techniques that we'll see later, like for loops, while loops. And one thing is you can define functions. And we can access like a function that I have defined here. And here we have the mcd function that has been defined. And the thing is, so far we have kind of seen how to execute several commands by piping into them. Kind of saw that briefly yesterday. But a lot of the time you want to do first one thing and then another thing. And that's kind of like the sequential execution that we get here. Here, for example, we're calling the mcd function. And we first are calling it with the makedir command, which is like creating this directory. Here, $1 is like a special variable, and this is the way that Bash works. Whereas in other scripting languages, there will be like argv, the first item of the array argv will contain the argument. In Bash is $1, and in general, a lot of things in Bash will be $something and will be reserved. We will be seeing more examples later. And when we have created the folder, we cd into that folder, which is kind of like a fairly common pattern that you will see. We will actually type this directly into our cell, and it will work, and it will define this function. But sometimes it's nicer to kind of write things in a file, and what we can do is we can source this, and that will execute this script in our cell and load it. So now it looks like nothing happened, but now the MCD function has been defined into our cell. So we can now, for example, do like MCD test. And now we move from the tools directory to the test directory. We created the folder and we move into it. What else? So as a result, there's like we access the first argument with $1. There's a lot more kind of reserved comments. For example, $0 will be the name of the script. $2 through $9 will be the second through the 9th argument that the bash script takes. Some of these reserved keywords can also kind of be directly used in the cell. So for example, $interrogation mark will get you the error code from the previous command, and which I will also explain briefly. But for example, $_ will get you the last argument of the previous command. So another way we could have done this is we could have, say, like nkmedir test, and instead of kind of rewriting test, we can access that last argument as part of using the $_ Like that will be replaced with test, and now we go into test. There are a lot of them. You should kind of familiarize with them. Another one I often use is it's called bang bang. You will run into this whenever you, for example, are trying to create something and you don't have enough permissions. Then you can do sudo bang bang, and then that will replace the command in there. And now you can just try doing that. And now it will prompt you for password because you have sudo permissions. Before I mentioned the error command, yesterday we saw that in general there are like different ways a process can communicate with kind of other processes or commands. We mentioned the standard input, which was like the less than like getting stuff through the standard input, putting stuff into the standard output. There are kind of a couple more interesting things. There's also like a standard error stream where you kind of write errors that happen with your program and you don't want to pollute the standard output. And it's also the error code, which is kind of like a general thing in a lot of programming languages of like some kind of way of reporting how the entire run of something went. So if we do something like echo hello, and we like query for the value is 0. And it's 0 because everything went okay, and there weren't any issues, and a 0 exit code is the same as you will get in a language like C. Like 0 means everything went fine, there were no errors. However, sometimes things won't work. Like sometimes, like if we try to grep for foobar in our MCD script, and now we check for the value is 1, and that's because we tried to search for the foobar string in the MCD script, and it wasn't there. So like grep doesn't print anything, but lets us know that things didn't work by giving us like a 1 error code. And there are some interesting commands like true, for example, will always have a 0 error code, and false will always have a 1 error code. And then there are like these logical operators that you can use to do some sort of like conditionals. For example, one way, you also have ifs and elses that we'll see later, but you can do something like false and echo oops fail. So here we have 2 commands connected by this OR operator. What bash is gonna do here is gonna execute the first one, and if the first one didn't work, then it's gonna execute the second one. So here we get it because it's gonna try to do the logical OR. If the first one didn't have a 0 error code, then it's gonna try to do the second one. Similarly, if we instead of use false, we use something like true, since true will have a 0 error code, then the second one will be short circuit and it won't be printed. Similarly, we have an AND operator, which will only execute the second part if the first one like ran without errors. And the same thing will happen. If the first one fails, then the second part of the statement won't be executed. Kind of not exactly related to that, but another thing that you will see is that no matter what you execute, then you can concatenate commands using a semicolon in the same line, and that will always print. Beyond that, what we haven't seen, for example, is how will you go about doing kind of getting the output of a command into a variable. And the way we can do that is doing something like this, where what we're doing here is we're getting the output of the pwd command, which is just printing the present working directory where we are right now, and then we're storing that into the foo variable. So we do that, and then we ask for foo, we get our string, and more generally, we can do this thing called command substitution, or by putting it into any string, and since we're using like double quotes instead of single quotes, the thing will be expanded, and it will tell us that we are in this working folder. Another interesting thing is right now, what this is expanding is to a string instead of kind of like this is expanding as a string. Another nifty and like lesser known tool is called process substitution, which is kind of similar. What we will do, it will here, for example, the less than parentheses, some command, and then another parentheses, that will do is that will execute, that will get the output to kind of like a temporary file, and it will give the file handle to the command. So here what we're doing is we're LSing the directory, kind of putting into a temporary file, doing the same thing for the parent folder, and then we're concatenating both files. And this might be really handy because some commands, instead of expecting the input coming from the stdin, they are expecting things to come from some file that is giving some of the arguments. So we get kind of both things concatenated. I think like so far there has been a lot of information. Let's see kind of like a simple, like an example script where we see a few of these things. So for example, here we're having like a string, and we have kind of this $date. $date is a program. So again, there's a lot of programs in Unix. You will kind of slowly familiarize with a lot of them. Date just prints what the current date is, and you can specify different formats. Then we have this $0 here. $0 is the name of the script that we're running. Then we have $has. That's the number of arguments that we are giving to the command. And then $$ is the process ID of this command that is running. Again, there's a lot of kind of these dollar things. They're not intuitive because they don't have like a mnemonic way of remembering, maybe $has. But it can be, you just kind of will be seeing them and getting familiar with them. Here we have this $add, and that will expand to all the arguments. So instead of having to assume that maybe say we have 3 arguments and writing $1, $2, $3, if we don't know how many arguments, we can put all those arguments there. And that has been given to like a for loop. And the for loop will, in time, get like the file variable, and it will kind of be giving each one of the arguments. So what we're doing is for every one of the arguments we're given, then in the next line, we're running the grep command, which just search for a substring in some file, and we're searching for the string foobar. In the file, here we have kind of put the variable of the file to expand. And yesterday we saw that like if we care about the output of a program, we can redirect it to somewhere to save it or like to connect it to some other file. Here, but sometimes you want the opposite. Sometimes here, for example, we're gonna care about the error code about this grep. We're gonna care whether the grep ran successfully or it didn't. So we can actually discard entirely what the output, like both the standard output and the standard error of the grep command. And what we're doing is we're redirecting the output to dev null, which is kind of like a special device in Unix systems where you can like write and it will be discarded. Like you can write no matter how much you want to there, and it will be discarded. And here's the kind of the greater than symbol that we suggested for redirecting the output. Here we have like a 2 greater than. And as some of you might have guessed by now, this is for redirecting the standard error, because those two streams are separate, and you cannot have to tell Bash what to do with each one of them. So here we run, we check if the file has foobar, and if the file has foobar, then it's going to have a 0 error code. If it doesn't have foobar, it's going to have a non-zero error code. So that's exactly what we check in this if part of the command. We say, get me the error code, again, this $, and then we have a comparison operator, which is NE for not equal. Unlike some other programming languages, we do have kind of like equals, bang equals, these symbols. In Bash, they're like kind of like a reserved set of comparisons, and it's mainly because there's a lot of things you might want to test for when you're in the cell. Here, for example, we're just checking for the two integer values being the same. But for example, here the -f check will let us know if a file exists, which is something that you will run into very, very commonly. Going back to the example, then what happens when we go into, if the file did not have foobar, like there was like a non-zero error code, then we print like this file doesn't have any foobar. We're going to add one, and what we do is we echo this like has foobar, hoping this is a comment to the file, and then we're using the pattern we suggested of like greater to append at the end of the file. And here, since the file has been fed through the script and we don't know it beforehand, we have to substitute the variable of the file name. We can actually run this. We already have like correct permissions in this script, and we can give a few examples. We have like a few files in this folder. MCD is the one we saw at the beginning for the MCD function. We have like some script function, and we can even feed the own like script to itself to check that like it has foobar in it. And we run it, and we can see that like these different like variables that we saw that have been successfully expanded. We have date has been replaced to the current time. Then we're running this program with 3 arguments. There's randomized PID, and then it's telling us, oh, MCD doesn't have any foobar, so we are adding a new one, and the bin in the script file doesn't have one. So now, for example, we go to MCD, it has the comment that we were looking for. One other thing to know when you're kind of executing the scripts is that here we have like 3 completely different arguments, but very commonly you will be given like arguments that can be more succinctly given in some way. So for example, here if we wanted to refer to all the .sh scripts, we could just do something like ls *.sh, and this is a way of kind of file name expansion that most cells have. It's called globbing. And here, as you might expect, this is going to say, oh, anything that has any kind of sort of characters and ends up with sh. So, unsurprisingly, we get kind of example sh and ncd.sh. We also have this project 1 and project 2, and if there were like we can do like a project 42, for example. And now, if we just want to refer to the project that have a single character but not 2 characters afterwards, or like any other character, we can use the question mark. So question mark will expand to only a single one. And we get like kind of, we're LSing first project 1 and then project 2. In general, kind of like the globbing can be very powerful. You can also kind of combine it. A common pattern is to use what is called curly braces. So let's say we have an image that we have in this folder, and we want to convert this image from PNG to JPEG, or we could maybe like copy it, or this is like really common pattern of have two more arguments that are fairly similar, and you want to do something with them as arguments to some command, you could do it this way, or more succinctly, you can just do image.open curly bracket, then PNG JPEG, and here I'm getting kind of some color feedback, but what this will do is like expand into the line above, and actually can like add CSH to do that for me, and that's what's happening here. This is really powerful. So for example, you can do something like, we could do touch and like a bunch of foods, and all of these will be expanded. You can also do it at several levels, and it will do the Cartesian. Yeah, we have something like this. We have one group here. There's like 1, 2, and then here is like 1, 2, 3, and this is gonna do kind of the Cartesian product of these two expansions, and it will expand into all these things that we can quickly touch. You can also combine the asterisk glob with the curly braces glob. You can even use kind of ranges of like, we can do like mkdir, and we create the foo underbar directories, and then we can do something along these lines. This is gonna expand to foo A, foo B, like all these combinations through J, and then the same for bar. Like I haven't really tested, but yeah, like we're getting all these combinations that we can touch. And now if we touch something that is different between these two, we can again showcase the cell, the process substitution that we saw earlier. Say we want to kind of check what files are different between these two folders. For us, it's obvious, we just saw it because it's X and Y, but we can ask the cell to do this diff for us between the output of one ls and the other ls. Kind of unsurprisingly, we're getting like X is only in the first folder and Y is only in the second folder. What is more is right now, we have only kind of seen bash scripts. If you like other scripts, like for some tasks, bash is probably not best. It can be tricky. You can actually write scripts that interact with the cell in a lot of different languages. So for example, let's see here, Python script. We have a magic line at the beginning that I'm not explaining for now. Then we have like import sys. It's kind of like in Python, it's kind of not by default trying to interact with the cell, so you will have to import some library. And then we're doing a really silly thing of just iterating over the sys.argv one semicolon, which is sys.argv is kind of similar to what in bash we're getting as like the $0, $1, etc., etc. It's like the vector of the arguments we're printing in the reverse order. And the magic line at the beginning is called a cbang, and is the way that the cell will know how to run this program. Like you can always do something like, oh, Python script, and then like ABC, and that will work. Like obviously, like that will work. But what if we want to make this to be executable from the cell? The way the cell knows that it has to use Python as the interpreter to run this file is using that first line. And that first line is giving it kind of the path to where that thing lives. However, you might not know, like different machines will have probably different places where they put Python, and you might not want to assume where Python is installed or any other interpreter. So one thing that you can do is use the env command. So you can also give arguments in the cbang. So what we're doing here is specifying or run the env command that is for pretty much every system, like some exceptions, but like for pretty much every system, is in user bin where a lot of binaries live, and then we're calling it with the argument Python, and then that will make use of the a path environment variable that we saw in the first lecture. It's going to search in that path for the Python binary, and then it's going to use that to interpret this file. And that will make this more portable, so it can be run in my machine and your machine and some other machine. Another thing is that the Bash is not really modern. It was developed a while ago, and sometimes it can be tricky to debug. And by default, the ways it will fail sometimes are intuitive, like the way we saw before of foo command not existing. Sometimes it's not. So there's a really nifty tool that we have linked in the lecture notes, which is called SaltCheck, that will kind of give you both warnings and syntactic errors or things that you might not have quoted properly and might misfire, have spaces in your files. So for example, for extremely simple MCD SH file, we're getting a couple of errors saying hey, surprisingly, we're missing a cbank, this might not interpret it correctly if you're running the different system. Also, this CD is taking a command and it might not expand properly. So instead of using CD, you might want to use something like CD and then an OR and then an exit. We go back to what we explained earlier. What this will do is if the CD doesn't end correctly, if you cannot CD into the folder because either you don't have permissions, doesn't exist, that will give a non-zero error command. So you will execute exit, and I will stop the script instead of continue executing, assuming you're in a place that you are actually not in. And I actually haven't tested, but I think we can check for the example SH. And here we're getting that we should be checking the exit code in a different way because it's probably not the best way doing this way. One last remark I want to make is that when you're writing Bash scripts, there are or functions for that matter. There's kind of a difference between writing Bash scripts in isolation, a thing that you're going to run, and thing that you're going to load into your cell. We will see some of this in the command line environment lecture, where we'll kind of be tooling with the BashRC and the syshrc. But in general, if you make changes to, for example, where you are, if you CD into a Bash script and you just execute the Bash script, it won't CD into the cell that you are right now. But if you have loaded the code directly into your cell, so for example, we sourced the function and then you execute the function, then you will get those side effects. And the same goes for defining variables into the cell. And now I'm going to kind of talk about some tools that I think that are nifty when working with the cell. The first, we was also briefly introduced yesterday. How do you know what flags or what exact commands can do? How am I supposed to know that ls -l list the files in a list format, or that if I do move -i, it's gonna prompt me for stuff. That what you have is the man command, and the man command will kind of have a lot of information of how will you go about. So for example, here it will explain for the -i flag, there are all these options you can do. And that's actually pretty useful, and it will work not only for kind of really simple commands that kind of come packaged with your OS, but it will also work with some tools that you install from the internet. For example, if the person that did the installation made it so that the man pages were also installed. So for example, a tool that we're gonna cover in a bit, which is called rigrep, and is called with RG. This didn't come with my system, but it has installed its own man page, and I have it here, and I can access it. For some commands, the man page is useful, but sometimes can be tricky to decipher, because it's more kind of a documentation and a description of all the things the tool can do, but sometimes it will have examples, but sometimes not, and sometimes the tool can do a lot of things. So a couple of tools that I use commonly are Convert or FFmpeg, which deal with images and video respectively, and the man pages are like enormous. So there's like one nifty tool called TLDR that you can install, and it will have like some nice kind of explanatory examples of how you want to use this command. And you can always Google for this, but I find myself saving like going into the browser, looking about some examples and coming back where like TLDR are like kind of community contributed and they're like fairly useful. Then like the one for FMPG has a lot of useful examples that are like more nicely formatted if you don't have like a huge font size for recording. Or even simple commands like tar that have a lot of options that you are combining. So for example, here you can be combining 2, 3 different flags and cannot be obvious when you want to combine different ones. That's how you kind of will go about kind of finding more about these tools. On the topic of finding, let's try learning how to find files. Like you can always go ls, and like we can go like ls, project one, and keep lsing all the way through. But maybe if we already know that we want to look for all the folders called src, then there's probably a better command for doing that. And that's find. Like find is a tool that pretty much comes with every Unix system. And find, we're gonna give it the, here we're saying we're going to call find in the current folder. Remember that dot stands for the current folder. And we want the name to be source. And we want the type to be a directory. And by typing that, it's gonna recursively go through the current directory and look for all these files or folders, in this case, that match this pattern. And find has like a lot of useful flags. So for example, you can even test for the path to be in a way. Here we're saying, oh, we want some number of folders. We don't really care that many folders. And then we care about all the Python script, like all the things with extension .py that are within a test folder. And we're also checking just in case. It's pretty silly, but we're checking just that is also a type F, which stands for file. And we're getting all these files. You can also use different flags for things that are not like the path or the name. You could check things that have been modified, like M time is for like the modification time, things that have been modified in the last day, which is going to be pretty much everything. So it's going to print a lot of the files we created and files that were already there. And you can even use other things like size, the owner, permissions, you name it. What is even more powerful is find can kind of find stuff, but it also can do stuff when you find those files. So we could look for all the files that have like a TMP extension, which is like a temporary extension, and then we can tell find that like for every one of those files, just execute the rm command for them. And that will just be calling rm with all these files. So let's first execute it without, and then we execute it with it. Again, as with like the command line philosophy, it looks like nothing happened, but since we have a zero error code, something happened. It's just like everything went correct and everything's fine. And now if we look for these files, they aren't there anymore. Another nice thing about the cell in general is that like there are like these tools, but people will keep finding new ways or like alternative ways of writing these tools, and it's kind of nice to know about them. So for example, find, if you just want to match like the things that end in TMP, can be sometimes weird to do this thing. Like it has like a long command, and there is like things that, like fd, for example, there's like a sorter command that by default will use regex, and you will ignore your Git files so you don't like search even for them, and it will color code. It will have like better Unicode support. It's like nice to know about some of these tools. But again, the main idea is that if you are aware that these tools exist, you can save yourself a lot of time from doing kind of menial and repetitive tasks. Another command to bear in mind is that like find, like for some of you might be wondering, like find is probably just, it's actually going through directory structure and looking for the things. But what if I'm doing a lot of finds a day? Wouldn't it be better doing kind of like a database approach and like build an index first and then use that index and update it in some way? Well, actually, most Unix systems already do. And this is through the locate command. And the way that the locate it will just look for paths in your file system that have the substring that you work. And I actually don't know if it will work. Oh, it's working. Let me try to do something like missing semester. It's going to take a while, but it's suddenly like it found all these files that are somewhere in my file system. And since it has like built an index already on them, it's much faster. And then to like keep being updated using like the update db command that is running through cron to update this database. Finding files, again, is like really useful. Sometimes you're actually concerned about not the files themselves, but the content of the files. For that, you can use the grep command that we have seen so far. So you could do something like grep foobar in MCD is there. What if you want to, again, like find recursively search through the current structure and look for more files, right? Like we don't want to do this manually. We could use find and the exec, but actually grep has like the -R flag that will go through the entire directory here. And it's telling us that, oh, we have the foobar line in example sh at these 3 places and in these other 2 places in foobar. This can be really convenient when mainly kind of the use case for this is you have written some code in some like programming languages and it's somewhere in your file system, but you actually don't know, but you can actually quickly search. So for example, I can quickly search for all the Python files that I have in my Scratch folder where I use the like request library. And if I run this, like it's giving me like through all these files exactly what line has been found. And here, instead of using grep, which is fine, like you could also do this, I'm using ripgrep, which is kind of like the same idea, but again, trying to bring some more niceties like color coding or file processing and other things. I think like has also very Unicode support. It's also pretty fast, so you are not paying like a trade-off on like this being slower. And there's a lot of useful flags. Like you can say, oh, I actually want to get some context around those results. I don't know if it committed, so yes. So I want to get like 5 lines of context around that. So I can say, like, see where that import lives and see kind of code around it. Here in the import is not really useful, but like if you're looking for where you use a function, for example, it will be pretty handy. We can also do things like we can search, for example, here, some like a more advanced use. We can say U is for like don't ignore like hidden files. Sometimes that can be then like you sometimes you want to be ignoring hidden files. Say first you want to search config files of that are like by default hidden. Then instead of printing the matches, we're asking to do something that will be kind of hard, I think, to do with grep out of like my head, which is I want you to print all the files that don't match the pattern I'm giving you. which might be a weird thing to ask here, but then we keep going, and this parent here is like a small regex, which is saying, oh, at the beginning of the line, I have a has and a bang. And that's a cbang. Like that, we're searching here for all the files that don't have a cbang. And then we're giving it like here like t minus sh to only look for like sh files, because maybe like all your Python or text files are fine without like a cbang. And here is telling us, oh, like MCD is obviously missing a cbang. We can even have like some also nice flags. For example, if we include the stats flag, I don't really actually write it there. It will get all these results, but it will also tell us like information about like all the things that it searched. For example, like the number of mats, the matches that it found, the match lines, the file that it searched, the bytes that it printed, etc. Similar as with FD, sometimes it's not as useful using one specific tool or another. And in fact, as regroup, there are like several other tools, like ACK is the original kind of grep alternative that was written. Then was like the Silver Searcher, AG was another one. And they're all pretty much interchangeable. So like maybe you're a system that has one or not the other, just knowing that you can use these things with these tools can be fairly useful. Lastly, I want to cover kind of how you go about not finding files or code, but how do you go about finding commands that you already sometimes like figured out. And the first obvious way is just using the up arrow and like slowly going through all your history and like looking for these matches. This is actually not very efficient, as you probably guess. So the BAS has ways to do this more easily. There's the history command that will print your history. Here I'm in CSH and it only prints some of my history, but if I say I want you to print everything from the beginning of time, it will print everything from the beginning of whatever this history is. And since this is a lot of results, maybe we care about the ones where we use the convert command to go from some type of file to some other type of file, some image, sorry. Then we're getting all these results here about like all the ones that like match this substring. Even more, pretty much all cells by default will link Control R, which is like a key binding, to do like backward search. And here we have like backward search where we can like type convert and it's finding the command that we just typed. And if we just keep hitting like Control R, it will kind of go through these matches and it will let us like re-execute it in place. Another thing that you can do related to that is you can use this really nifty tool called FCF, which is like a fuzzy finder. Like it will let you do kind of like an interactive grep. And we could do, for example, this where we can cut or example sh command that will print it to the standard output, and then we can pipe it through FCF, and it's just getting all the lines, and then we can interactively kind of look for the string that we care about. And the nice thing about FCF is that if you enable the default bindings, it will bind to your controller cell execution, and now you can quickly and dynamically like look for all the times you try to convert a favicon in your history. And it's also like fastly matching, whereas like by default grep or these things, you cannot have to write a regex or like some expression that will match the thing here. Here I'm just typing convert on favicon and it's just trying to do the best it can doing the match in the lines it has. Lastly, a tool that probably you have already seen that I've been using for not retyping these extremely long commands is this history substring search, where as I type in my cell, and both failed to mention, but both Fizz, which I think was who originally introduced this concept, and then CSH has a really nice implementation, will let you do is as you type the command, it will dynamically like search back in your history to the same command that has like a common prefix. And then if you like it will change as the match list stops working, and then as you do like the right arrow, you can like select that command and then like re-execute it. Let me get some more. I've seen a bunch of stuff. I think I have a few minutes left, so I'm gonna cover kind of a couple of tools to do kind of really quick directory listing and directory navigation. So you can always use the -R to kind of like recursively list some directory structure, but that can be like suboptimal. Like I cannot really make sense of this easily. There's like a tool called tree that will be like the match more like friendly format, like print all the stuff. It will also color code based on here, for example, foo is blue because it's a directory, and like this is red because it has execute permissions. But we can go even further than that. There's like really nice tools. There's like a recent one called Brute that will do the same thing, but here, for example, instead of doing this thing of listing every single file, for example, in var, we have these A through J files. It will say, oh, there are like more unlisted here. And I can actually start typing, and it will, again, fastly match to the files that are there, and I can quickly select them and navigate through them. So again, it's good to know that you're not like that these things exist, so you don't lose like large amounts of time like going for these files. There are also, I think I have installed also like something more similar to what you will expect your OS to have, like Nautilus or like one of like the Mac Finder that has like an interactive input where you can just like use your navigation arrows and quickly explore. It might be overkill, but you'll be surprised how quickly you can make sense of some directory structure by just like navigating through it. And pretty much all of these tools will let you edit or like copy files if you just like look for the options for them. Last addendum is kind of going places. Like we have CD, and CD is nice. Like CD will get you to a lot of places, but it's pretty handy if you can like quickly go places you are either you have been recently or that you go frequently. And you can do this in many ways. There's probably, you can start thinking, I can make bookmarks, I can make aliases in the shell that we will cover at some point, symlinks. But at this point, like programmers have like built all these tools, so the programmers have already figured out a really nice way of doing this. And one way of doing this is using what is called AutoJump, which surprisingly is not loaded here. This is concerning. Oh, no. Okay, yeah, no worry. I will cover it in the command line environment. I don't know why it's not live. I think it's because I disabled the controller, and that also affected other parts of the script. I think at this point, if anyone has any questions that are like related to this, I'll be more than happy to answer them if anything was left unclear. Otherwise, there's like a bunch of exercises that we wrote kind of touching on these topics, and we encourage you to kind of try them and come to office hours where we can help you kind of figure out how to do them, or like some like Bash quirks that are not clear.